Swayam Prabha. Digital India. Educated India.
Welcome to the lecture on case study using regression. In the last lecture, we looked at the variables price, power PS and year of registration. So after arriving at the working range, let's look at the variable price. Now we've plotted a histogram for the variable price here. This is after narrowing down the range. Now I've again used ggplot function here, and to plot the histogram, I've again used geo_histogram. Now within the histogram, to plot the probability density, you need to give the parameter y is equal to ... density ... and that is within the aesthetic function, and you need to give geom_density as well. Everything else remains the same. Once executed, you get the following histogram. On x-axis you have price, on the y-axis you have probability density here because we've plotted the density. Now this histogram is a lot better compared to the earlier histogram because here we are able to clearly see the bins here. This distribution is skewed. So this means there's a particular range of values within which there are more frequently occurring records, and that is something very clear from this histogram. So now let's look at a box plot to look at the spread of this data. The function remains the same like what we earlier used, but here you can see that there is a clear cut box that's available. Of course, there are a lot of values that are above this range, but then now we are able to look at the distribution of these values, and your median is here. So that is something very good about it because you're able to clearly interpret now from this box plot. So now let's look at the variable power PS. Now if you look at the variable power PS after narrowing down, this is the histogram. Again I have plotted the probability density. On the x-axis you have power PS, on the y-axis you have the density, and here we can clearly see that after narrowing down the range, the distribution is much more clearer for this variable. We can see here that this bin between 60 to 70 has most number of values. This distribution is not symmetric, it's a little skewed. But then yes, of course, it's a lot better compared to the earlier histogram that we plotted for power PS. Now let's look at the distribution of power PS again using a box plot. So here you can clearly see that this is the median. The median is roughly at 120, right? And of course, there are values higher than the whiskers. These are extreme values. But then now you have a clear-cut box plot that shows a clear distribution. So we are going to be treating these as extreme values. But then now this is a better box plot compared to the earlier one that we got without narrowing down the range. So to further simplify variable reduction, we are going to be combining year of registration and month of registration. Now month of registration is an integer like how we know. So we are going to just divide each of the month by 12. So what we are going to do is we are going to take the year 2018 and subtract the year of registration. So that plus the month of registration gives you the new variable called age. For instance, let's say if a vehicle was registered in the year 1950, then 2018 minus 1950 would be 68. That would give you the first half of the age. And let's say it was registered in a month called May. So 5 by 12 basically gives you a decimal point that you need to add to 68 to give you the entire age, to give you the entire value of age. So that is what we are going to do. So first we are going to divide month of registration by 12. And subtract year of registration from 2018 and then add the month of registration. And this entire operation I am saving it under a new column called age that I am creating under the data frame cars. So once we execute these set of lines, we can get a 5-number summary for the variable age. So the minimum is 0, the first quartile is at 10.33, median is at 14.83, so mean is at 14.87. The third quartile is at 19.17 and maximum is at 67.75. So with this, it's clear that 3/4 of your data has an age value of less than 19 and the maximum value is 67. What we can also see here is that the median and the mean, both of these are very, very close by. So they are almost equal, and this shows us that it is symmetric. So age is symmetrically distributed around the mean value, and the minimum is 0, which signifies that there are cars which are very brand new. So this is how you infer the fine number summary for the variable age. So now that we have used year of registration and month of registration to create a new column called age, we are going to drop these two variables because we have already created a new column with these information, and if you are going to retain them in your data, then it means that there is a redundancy in your data, right? So that's why we are going to just drop these two columns, and the command is very simple. It's like how we've used it earlier. So from cars, I am dropping column names that belong to year of registration and month of registration. So after dropping year of registration and month of registration, you will notice that the number of columns is 13, and that's because we've created one extra column called age. So that makes the total number of columns as 15, and when we are 2 down, it brings it to 13. So let's understand the variable age now. What you see here is a histogram for the variable age, and we've plotted the density of this variable, and you can clearly see that it's more or less symmetric except for the ends. So the variable age is more or less symmetrically distributed. So it's more easy to comprehend the variable age compared to year of registration and month of registration, and that's the reason we've combined both these variables to create a new variable called age. So now let's understand the effect of age on price. Now I am plotting a scatter plot to understand the effect of age on price. Now this is again the same ggplot and the geom point function that you need to use. On the x-axis I have age, on the y-axis I have price. So on an overall note, we can see that as age increases, the price decreases. Now apart from this, there are cars with a very high age, but then their price is also high. Now these cars can be treated as vintage again, so there is nothing wrong in including them, but you need to cull out that data separately to understand more on what can be the possible trends. So as age increases, it's clear that price decreases, right? You can see that with increase in age, the price drops, but then beyond a certain point, with increase in age, the price also increases, and such cases can be treated as the cases of vintage cars. So now let's understand the influence of power PS on price. So here you can see that with increase in the horsepower of the car, the price also increases. So that is very evident from this plot itself. So more the horsepower, more the price, because the specification of the car is going to be good, and hence the price increases. Now this brings us to the end of part 1 of the data preparation and exploratory data analysis. Now the second part is where we are going to understanding other variables which are more categorical in nature. So now let's start by exploring all these other variables and understand their importance and whether they influence price or not. So the first variable that we are going to look at is seller. Now this variable basically has two levels, one is commercial and the other is private. Now to understand the frequencies of each of these, I have used the table function. Which will basically give you their corresponding frequencies. So this variable basically has two categories, one is private, other is commercial. Now to understand the frequencies of each of these categories, we have used the function table, and I have given the variable seller within parenthesis. Now once you execute this function, you will see that number of records which has seller as commercial is 1, and all the other records have seller as private. So in this data, it's as good as having the entire column as private. So if you can look at the proportion table, so to access the proportion table, I've used the function prop.table, and within parenthesis, I've given the same table function again and just multiplied it by 100. So what this function returns is basically the proportions in percentages, and you can see that commercial constitutes to about 0.002%, and private is majority, which is 99.99%. That is also evident from the bar plot here. So to plot the bar plot, we've used ggplot function again from the data cars, and within aesthetic, the X is basically the seller. I have also filled this color inside for the variable using seller. So each of these categories will be colored differently. So you can hardly see anything under commercial, which shows there's only one record under this category, and majority of the data has seller as private, right? And again for the bar plot, you need to use the function geom bar. I've just colored the outline as black, and the aspect ratio of this is 1. So it is evident that fewer cars have seller as commercial. So it's as good as the entire column having seller as private. So this variable is going to be treated as insignificant, and we are going to drop this variable. So the next variable that we are going to look into is offer type. Now again, we are trying to understand the frequencies of each of the categories under offer type. One is offer, the other is request, and it's very clear that for all the records, offer type is always on offer. and that makes their proportion 100%. So we can right away drop this variable, and even if you check the bar plot, you can see only one kind of category here. So all cars have offer type as offer, and therefore this variable is insignificant. The next variable that we are going to look into is called A/B test, and around 20,644 records come under control, and under test you have 22,128 records. If you look at their proportions in terms of percentages, you can see that control constitutes about 48.2% and test comes to about 51.7%. The proportions are more or less equal. So we need to take another variable to understand their significance, and what we see here is just a bar plot, and it's also very clear that for both these categories the percentages are almost close, they are 50-50. So there's nothing much we can just infer from the categories alone or the bar plot alone, which is why we need to look at the third variable to understand their significance. So the next variable that we've taken to understand the significance of A/B test is price. Now what we plotted here is a box plot. Now let me just first take you through the command. So again, ggplot is the function we are using. Under data we are using the cars data. Under aesthetic we are giving the x as A/B test because we are going to understand the influence of A/B test over the variable price, and then that is again split based on the two categories that exist in A/B test. Now y is basically price, so we are trying to study the influence of A/B test on price, and I am filling both the boxes using the variable A/B test. So for the box plot you need to use the function geom_boxplot, and I am setting the aspect ratio of the plot to 1. So this is more like a 50-50 case. So for every price value you have a 50-50 distribution, and even from the earlier bar plot it was very clear that both the categories had an equal distribution. So there's nothing much we can infer from this except for the fact that for every price value there is a 50-50 distribution, and it also does not affect price because you can clearly see the medians of both the boxes are the same, and hence this variable is insignificant. Let's look at vehicle type now. What you see here is the count of all the categories here. So you can see that limousine has the highest number of count, right, and followed by that you have small car and station wagon. So in terms of percentage, limousine constitutes about 29.4% in this data, small car is at 23.27% and station wagon at 20.24%, and the remaining percentages are distributed across the other vehicle types. So now let's look at a bar plot to understand the counts better. So it's very clear that limousine has the highest count, followed by small car and then station wagon, right? So this is a bar plot for all, and you can see that I have filled the colors based on the categories in the vehicle type. So now that we are given the categories, we are going to understand their influence on the variable price. So what you basically see here is a box plot. Again, on the x-axis I have vehicle type, on the y-axis I have price, and the filled colors are again based on vehicle type. So this is a box plot to understand the effect of vehicle type on the price, and clearly you can see that the type of vehicle affects price, and therefore we know that this is very significant. So the median price of bus is very different from that of an SUV. So this clearly shows that vehicle type does indeed affect the variable price. So this variable is going to be retained further. Now the next variable we are going to be looking at is gearbox. Gearbox again has two categories, one is automatic, the other is manual. Now automatic has around 9,396 records, and under manual you have 32,582 records. In terms of percentages, manual constitutes about 77.6% and 22.47% is for automatic. So this is also very clear from the bar plot. So what you also see under gearbox is NA, and here you can see that automatic has lesser count compared to manual. So let's understand the influence of gearbox over the variable price. So here what we have is a box plot. On the x-axis you have gearbox, on the y-axis you have price. If you look at the medians for each of these, you can see that the median price of automatic is much higher compared to the median price of manual gearbox. So clearly the type of gearbox affects the price, and hence it is significant and it will be retained. Now coming to the variable model. Now model has several categories under it, and even in terms of percentages it's not very clear to understand because it has a lot of categories to it. So it's not very clear to interpret from model, but you can surely see that not all of the models have a higher count, only some of the models have a higher count from this bar plot. And further to strengthen our understanding, what this is a box plot, but because of the number of models that are involved in this, it's not very easy to interpret the distribution of price for each of the model. But on an overall level, we can see that the price distribution is very different across the models, and therefore we are going to treat this variable as significant and consider it for modeling. Now the variable kilometer again is more like a qualitative integer. You will see that there are several levels of kilometers here. So just to understand how many records fall under each of the kilometer type, we've just used the function table. Now we can see that majority of the data has kilometer as 150,000. So that's about 27,430 records have kilometer as 150,000. And in terms of percentages, 64% of your data has kilometers equal to 150,000. So that's something that we can interpret from here. Now if you look at the fine number summary, we can also clearly see that 3/4 of the data has a kilometer less than or equal to 150,000, and the maximum is also 150,000, and majority of the records have a kilometer of 150,000. Coming to understanding the influence of kilometer over price, we are going to be using a scatter plot. So we are not able to clearly understand the influence of kilometer over price, and that is because since these are qualitative values, these are integer values, and there are only a few of them. You can see that each of them are clustered separately, and you really don't see an overall trend. So what we are going to do is, just for the sake of our understanding and just for box plot, we are going to convert kilometer as first a categorical variable and then reconvert it back to an integer once we are done with the analysis. This is just to make sure that we are able to plot a box plot for each of the individual kilometer level. So to convert it to a categorical variable, you need to use the function as.factor. So what you see here is a box plot, and this is to understand the influence of kilometer over price. So clearly you can see here that different kilometers have basically different price values, and the greater the kilometer, the lesser the price, and that's evident from the median. So now that we know that kilometer influences price, we are going to keep it because it's significant. But before we move further, we are going to convert it back to an integer again using the function as.integer. And we are making the changes again in the same data frame. So let's look at the variable fuel type. Now this variable tells you the type of fuel that's used in the car. Now there are different categories. You have CNG, diesel, electro, hybrid, LPG, others, and petrol. So in this data, majority of the records have petrol as the fuel type, followed by diesel, and then you have LPG, and then you have CNG. So that is the count. In terms of percentage, petrol constitutes 65.98%, and then followed by that you have diesel, which is 31.99%. So petrol and diesel put together constitutes for majority of the records. So in terms of bar graph, let's just understand how to visualize the frequencies. So you can see that petrol has the highest frequency, followed by diesel. With regard to the others, we are not even able to see their bars, and that's because of their low frequency. So we are trying to understand whether fuel type affects price or not. So different fuel types have different median values for prices. So yes, fuel type does affect price, and hence it's going to be considered for modeling. Now coming to the variable brand, there are several bands. We have the frequency here and their corresponding proportions in percentage. But out of all these variables, Volkswagen has the highest frequency. It constitutes about 21.3% in the entire data. So let's just understand this a bit more deeper using a bar plot. So here also you can see that Volkswagen has the highest frequency, followed by Audi and BMW. That's something that's very clear from the bar plot and from the frequency and the proportion value. So let's see if brand influences price or not. So we are plotting the box plot for brand on the x-axis and price on the y-axis. So here you can clearly see the distribution of price is varying across each of the brands. Even though you're not able to see any of the brands on the x-axis, you can clearly see there's a dip and then there's a peak. So the median price for each of the brands is going to be very different, and hence it's going to be considered in modeling. Now coming to the variable not repaired, damaged. Yes, basically tells you that the car was damaged, but the damage has not been rectified. And no basically tells you that the car was damaged, but the damage has been rectified. For majority of the cars, the damage has been rectified, and that is given under the category no. For 3,998 cars, the damage was not rectified, and this basically means that 10.9% of the cars are those where the damage has not been rectified, and in the remaining 89%, the damage has been taken care of. So that is what this means, and this is further clear from this bar plot. And for majority of the cars, the damage is rectified, so you can see that they are higher in number. there are a few cars where the damage has not been rectified, and of course there are some NAs as well in this. So we are going to use a box plot to understand whether the variable not repaired damage, does it influence price or not. Now on the x-axis you have no, yes, of course I have the third category which is missing value, that's represented as NA. But let's just take the two categories, no and yes, and let's understand their influence on the variable price. So here you can see that the median for the category no is higher compared to the median for the category yes. So as expected, you can see that the cars that require the damages to be repaired, they fall under the lower price category. So yes, we do know that not repaired damage affects price, and hence it's significant, and hence it's going to be retained for modeling. So our next step is to basically remove the insignificant variables. So we earlier started with 42,772 records after arriving at the working range, and after creating the variable age, we have 13 columns now, and we have already dropped year of registration and month of registration. So that makes it 13 variables. Now in addition to this, we are also going to remove seller, offer type and A/B test, and once you remove them, you can see that you're left with 10 variables, but the number of records have been untouched, only the columns have been dropped. So it's important that we remove insignificant variables and we understand how does the remaining variables influence the variable price. So that's what we have done, and we have removed the insignificant variables, and now the dimension of the column has been reduced to 10. The next part of this analysis is to understand the correlation between numerical variables. So between the numerical variables, which is price, power PS, age and kilometer, are they related amongst themselves or are they related to the output price in any way? To find the correlation, I am going to create a correlation matrix. So basically you will see the same variables on the x and the y axis. So what you see here is the correlation matrix, and you can see that I have used the function core. So by default the function core gives you a Pearson correlation. Now if you don't want a Pearson correlation, you can basically look at other kinds of correlations which are Spearman and Kendall, and they are for ranked data, ranked and ordinal data. So that is something you can explore on. So just to arrive at the correlation matrix, I am giving the x-axis, and from the cars data frame I am accessing all the columns, and the same becomes the input also to the y variable. So correlation is calculated between two variables. So I don't want to calculate between two variables in every step, so I just extract all the variables together and give as an input. Now once you print the correlation, this is a correlation matrix that you will get. So price versus price is always 1. So you can see the entire diagonal has a value 1. So the correlation matrix is actually a mirror image. You can either take the lower triangle or the upper triangle, but the value is going to remain the same. So a correlation value which is very close to plus or minus 1 is considered to be very, very good, but a correlation value around 0 is considered to be very poor. Any value closer to plus or minus 1 is good. If it's more close to plus 1, it's positively correlated, and if it's more close to minus 1, then it means it's negatively correlated. Now if you look at this table, you can see that most of the correlation values are low, some are extremely low. For an instance, power PS in kilometer, that's very, very poor, it's almost 0, it's minus 0.02. So you can see that the correlation is very poor. But in this objective, what we are specific about is to understand the correlation of all the input variables with the output. We are interested in understanding how age, power PS and kilometer, how are they correlated with price. So that is what we are interested in. So I am just going to sort these variables in the decreasing order, and I am just going to print their values, because this gives me the correlation with price. I am going to take all the values from the first column, and I am just going to sort them in the decreasing order. And the function na.omit, right, and input becomes cars. So this omits all rows with one or many missing values, and the remaining data is stored under the data frame cars_omit. Just to quickly check the dimension of this data frame, it has 32,884 records and 10 columns. We started earlier with 42,772 records and now we've come down to 32,880. So we have roughly lost around 10,000 records here. Now once you do this, we are going to write the cars_omit data frame to a CSV file, because every time you keep running this whole program again, you have to start from scratch. It's as good as just writing this data frame to a CSV file, and you can just read the CSV file to proceed further with model building. And that way you can separate your codes as data preparation in EDA as one part and then model building as a second part. So we are going to use the function write.csv to write this data frame cars_omit as a CSV file titled omitted_data_cars_sample.csv. So you also need to give the extension. So once you write it, it gets saved as a CSV file in your current working directory, and you can again use the function read.csv to just read this file. So this is the data frame name that has the omitted data, and if you look at the dimension, you can see that it has a dimension of 32,884 records and 11 columns. But we know that it had only 10 columns. So if you look at the number of columns that you have, it reads an extra column called X, which we need to get rid of. So to just get rid of this, you can use cars_omit_data, right, and just omit the first column by giving a negative sign in front of it. So this omits the first column and the remaining columns get updated. So you can now check again the dimension and the names. You will see that there are only 10 columns and we've gotten rid of the column X. So we are going to be going ahead, we are going to work with this data frame, that is cars_omit_data, to build our model for linear regression and random forest. So this brings us to the end of the second part of data preparation and EDA, and in the next session we are going to be looking at model building using the omitted data for linear regression and random forest regression. So to summarize, in this lecture, after narrowing down the range, we revisited the variables price and power PS and understood how does their underlying distribution look. For the variable year of registration, we combined year of registration and month of registration and arrived at a new variable called age that helps us better in understanding or comprehending the whole influence of age over price. And we also looked at the categorical variables and understood their significance. So some of the categorical variables, we identified them as insignificant and hence we dropped them from the data, and with the remaining set of variables that we have, we basically omitted all the missing values from the data, and we have a final data set without any missing value that we are going to use for model building. Now along this process, we have also learned how to look at different variables and what are the different techniques to identify a variable's significance. So we've looked at frequency tables, we looked at proportion tables, we looked at bar plots, and what we've also learned is how to combine a categorical variable and a numerical variable and understand whether that categorical variable does it really influence the numerical variable. Thank you.